Hi guys. Um, this video is going to try to help you while you're on the road in Chile. And I'm going to, in this one video, introduce sections 3.1 and 3.2 at the same time. And if you're following along in the book, and hopefully you downloaded your PDF file for the text, I'm on pages 73, 74, then there's homework, and then there's, in section 3.2, there are some more postulates and theorems, and those are on page 78 and 79. So let me start off, and I just want to give you an overview and go over some definitions here that you're going to see. So I guess, obviously, the first definition is parallel. What is meant by parallel lines? What is meant by skew lines? And really, this is you probably understand this pretty well, but we've defined a line as a geometric figure such as this. It's composed of a continuum of points, and we often label it by 2 points, A, B, but also get used to saying that maybe that this is line L. Okay? And common for us in this section to say, all right, we have a second line, and this is line, let's say, M. And if we want to, in the nomenclature, say that these two lines are parallel, what you'll see in the text and what you will see pretty much everywhere is line L is parallel to line M. And it's this double hash here that means parallel. It means they do not intersect. So if you look carefully, please, on page, at the introduction of chapter 3, on page 73, they take a great deal of time to talk about parallel lines and then skew lines. So parallel lines are lines that are in one plane that do not intersect. They do not intersect at all. Skew lines are lines that are non-coplanar. So they are neither parallel nor intersecting. So I generally speak of simply, here we have parallel lines or non-parallel lines, and by that I mean they are in the same plane. So here is our diagram. We have two lines, line L and line M. And I've told you how to look for in the text and how to represent that. Okay, I'm going to change some colors here. Now, what we're going to do is have these two parallel lines, and we're going to cut them by another line that cuts both of them. Like that. And this line is called a transversal. And when we say transversal, we're generally going to assume that this line cuts both of these two parallel lines. Now, carefully look at this and look above, inside, and outside these two lines cut by this yellow transversal. You will see that we have 1, 2, 3, 4, 5, 6, 7, 8 resulting angles. These resulting angles all have specific names. So, if we have alternate interior angles, well, it is as it sounds. We have interior, and what that means is interior to the parallel lines. We have 1, 2, 3, 4 such interior angles. And in this case, we say alternate interior. Now, alternate means opposite. So in this case, 2 and 4 are opposite pairs of alternate interior angles, as are 1 and 4. Similarly, if we want to look at Same side, interior, those would be 1 and 3, as well as 2 and 4. Same side, interior. Now, you guys, make a card on this. Totally fine, and I encourage you to make a card with all of this information on it. And again, I'm right on page 74 in your text, so you'll be able to follow along easily as well. Now, corresponding angles are two angles in corresponding positions relative to these two lines. So let's go grab yet another color here and say corresponding angles, again, correspond to positions relative to the two lines. So we might want to label further here. So 5, 6, 7, and 8. It's probably a little unfortunate I didn't use the same numbering as the book, but that's okay. Corresponding angles refer to the same side. So we have corresponding angles in this case are 5 corresponds to 3, and 1 corresponds to 7, 6 to 4, and 2 to 8. So we have 4 pair in there. We have 4 pair of corresponding angles. Now, those are all the definitions that really we're going to use for the rest of the year about parallel lines. Once again, parallel, they do not intersect. And we assume that they're in the same plane. We have 2 lines, and if we know that these 2 lines are parallel, here is how we know that. L is parallel to M, and you'll see that in the text and everywhere, SATs, etc. We have 1, 2, 3 types of nomenclature for the resulting angles. So if you simply draw 2 parallel lines, use a yellow here if you will, transversal, which is that. Then you create 8 angles. All 8 of those angles have special names. So now the next page or the next video, I'm going to talk about some of the theorems that involve these angles.